Authid current user allows the resolution of external references to happen based on the privileges of the user calling the program. So here is the same function updateEMP in the demo schema, but now it is defined as authid current user. The demo schema contains the employee table. Here is the test schema, but this time it only has the table and the function has been removed from here. Now when the demo session issues the updateEMP call, as before, it goes to the updateEMP function where the update to the employee table acts on the employee table in the executed schema or demo schema. But when the test session runs the demo.updateEMP function, it goes to the updateEMP function in the demo schema as before, and here the update to the employee table resolves it to the employee table in the test schema as it is the caller or executor of the program. Here we have defined the function in the demo schema, but you may as well define it in the test schema or another central schema from where everyone can call it. So this is how the invoker's write authid clause can help in removing duplication of code in cases where identical table structures exist in multiple schemas and the same subprogram is to be used for all. However, since Oracle has to do a runtime resolution of external references, there is a slight performance hit, something you must be aware of, and so create subprograms with authid current user only when you have a real need for them. The other risk creating an invoker's write subprogram is of trust. If the definer of the procedure puts malicious code in the procedure, at runtime it is going to be executed on the invoker's tables and may cause malicious updates over there. Or the owner may create a subprogram initially as a definer's write subprogram and later, without the knowledge of the executor, recompile it as an invoker's write subprogram with some malicious DML statements inside it. Now when the executor runs the procedure, it will cause unintended updates which the owner of the subprogram may not have the privs himself of doing. One of the risks you need to be aware of. In most organizations, there is a build configuration process with multiple levels of testing, so hopefully the chances of this kind of thing happening is very low. Now the authid definer clause resolves everything in the definer's schema, but the authid invoker clause checks the privileges of the current user at runtime and resolves external references to tables, views, etc. in the schema of the invoking user. However, there is a limitation in terms of what operations are eligible for such resolution. So it can resolve external references only in these operations. DML statements in the select, insert, update and delete statements. So as we saw, it could resolve the employee table reference in the update statement in the last example in the calling user's schema. It can similarly resolve external references to say tables in the open and open for cursor statements. If you need to review cursors, please refer to the Part 1 course. We haven't looked at dynamic SQL yet, but dynamic SQL lets you build SQL statements which are built and evaluated at runtime as opposed to compile time. We will not go in much detail over here, but you can use execute immediate statements, open for using, or dbms SQL.parse statements for running dynamic SQL statements. These are also eligible for the invoker's write resolution for external references. For the sake of completeness, let me also mention that lock table transaction control statements, which allow you to specify locks yourself, can also be used to resolve external references when used in invoker's write program. For all other statements, the privileges of the owner are checked at compile time and external references are resolved in the schema of the owner. So if you are directly calling another procedure or function or package in your invoker's write subprogram, the reference to these will be resolved like definer's write subprogram in the schema of the defining user. Let us understand it with an example. So here is the same function we looked at defined with the invoker's write clause. Along with issuing the update to the employee table, our function updateEMP also calls another function called getEMPCount inside it. the function is present in the demo schema. Let us say getEmpCount function exists also in the test schema. Here is our demo session. Now, when from the demo session we call the updateEmp function, the employee table reference in the update statement gets resolved to the employee table in the demo schema as before. GetEmpCount function also gets resolved to the getEmpCount function in the demo schema, as demo schema also happens to be the owner schema of the updateEmp function. Let us say we have another session running as user test. Inside the anonymous block, it calls the demo.updateEmp function. Then as before, employee table reference gets resolved to the employee table in the test schema as it is used in an update or a DML statement. But the call to the getEmpCount function will resolve to the schema of the owner, which is demo in this case. This is one thing you need to be aware of. So if there is a direct subprogram call as the function call in our example, which is not a part of a DML statement but as a part of a SQL expression, it will always get evaluated to the subprogram in the schema of the owner. If you want it to be evaluated in a particular schema, then you have to qualify it, like in our example, test.getEmpCount, to make it go to the getEmpCount function in the test schema. If you do not qualify it, then it will get resolved to the schema of the owner. However, if you invoke the function as a part of a SQL statement, instead of calling it directly in an expression, you write it as select getEmpCount into lcount from dual. Now, since it is a part of a DML statement, references to getEmpCount will get resolved in the invoker's schema. So when demo session calls it, it will get resolved to the function in the demo schema, and when test session calls it, then it will get resolved to the function in the test schema. So this way, both the update statement call and the function call get resolved to the invoker's schema. However, not all functions can be called from SQL statement, and it has to qualify the restrictions we talked about in calling functions from SQL module.